The SP weapon system is a V-SHORAD ground-to-air missile system, and as with any such system, has a very short target detection to engagement timeline. One of the challenges for the human factors specialist in such a system is to optimize the system design to minimize the engagement timeline through the provision of an effective user interface, while also minimizing the crew workload and stress.
Engage. System on. Firing.
One of the main objectives of the ADAPT program is to address known obsolescence in the SP weapon system to ensure through-life supportability out to an out-of-service date of 2020. In addition to addressing obsolescence, a number of capability enhancements have been introduced to the existing weapon system, namely the addition of an auto-target tracker system, an ADAD IR surveillance video, a laser rangefinder, and the ability to fire the new lightweight multi-mission missile. All of these capability enhancements have a direct impact on the crew's MMI. The SP weapon system is operated by a two-man crew consisting of a tactical controller and the operator. The tactical controller is primarily responsible for the overall situation awareness and track management, ensuring that the weapon system engages the highest priority threat against the protected asset. The operator's role is essentially one of target acquisition, target tracking, target information reporting such as the target's range, its type, its crossing rate, and eventually missile engagement. His primary role is to ensure that the target is successfully engaged when commanded to by the tactical controller. The Master Gunner is our main point of contact within the user community and has been involved throughout the design process from the early concept phase through to system verification and acceptance. Typically we meet on a bi-monthly basis, but we are also in regular contact, and where required, ad hoc meetings can be arranged to address specific issues. One of the main operator HMI areas to be impacted by the inclusion of enhanced capability was the operator's firing handle. Early human factors analysis and task analysis activities identified an additional 4 functional controls to be added to the 7 controls on the existing firing handle. In addition to adding these extra controls, we wanted to address some of the known issues that were highlighted during the ongoing user discussions. Due to the long lead time associated with the hardware design, it was important that the ergonomical design issues were addressed early in the design phase. Once the extra controls had been identified and clearly understood, a number of CAD design options were created for the new firing handle. These were reviewed with the Master Gunner, and once the preferred option had been agreed, the prototype handle was manufactured and populated with the new controls and switches. Typically, this process took 48 hours. An ergonomic assessment was then conducted, and if required, modifications identified. The process was then repeated until an acceptable solution was reached. The complete process from concept design to agreed solution was probably in the region of 2 to 3 weeks.
It's important that we form a relationship early on with the engineering team, and therefore we can look at the requirements and get a perspective, particularly from the user, on a tactical view, and therefore using my experience as the user to explain to the engineering team what it is that I require. And to give you an example of this would be on the system with the tactical controllers console, where I was an integral part of the MMI design. I was able to discuss with the engineers about receiving the information in the right place at the right time, having given them my tactical experience on using this system in the field. Another example would be with the operator's control console, where we were able to discuss the switch positioning, and that allowed me as the user to optimize them switch positions for a tactical engagement.
One of the main aspirations of the system design team was to improve the tactical controller's user interface, as his current workload is compounded by having to process information from a number of different sources and functionally separate user interfaces. In the existing weapon system, the tactical controller has to process track information from the track display, which is overlaid on the target image display. He also has to relate this information to the weapon control orders, which are presented on a separate display and are received relative to grid north, while the vehicle may be pointing in a different direction. In parallel to this, he also has to be conscious of what the weapon operator is doing to ensure the operator is tracking the correct target, and he also has to be aware of the system status switches on the operator's console. These tasks are all happening within the high-stress environment of a VSHORAD defence system, where the crew are conscious that they are likely to be the primary target for any attacking aircraft. We have worked very closely with the user community to design a solution which presents the information on a single touchscreen-based user interface that not only displays the right information at the right time, but where possible automates some of the processes that were previously carried out manually. For example, the target icons are now automatically overlaid on the appropriate weapon control order, thus saving precious seconds in the engagement timeline. The preferred design option was then implemented and tested internally before being presented to the user for test and assessment in the HVM Synthetic Environment Integrated Test Platform. In the test platform, we were able to assess the MMI under very high-stress, target-rich environments. Any issues identified were recorded and updated for the next design phase. These design phases were repeated until the vast majority of the MMI was complete. The process is still ongoing, with minor updates being implemented even today.